Hello guys, welcome back to our fun channel where we do fun things all day, all time. So today I've started off doing some small complex circuits like this. I've called it an infrared speedometer because it uses infrared sensors right here, and they are being used as a motion sensor. So they're going to record how fast your motion was by counting how many LEDs have gone on once something has moved on top of them. So that's pretty much what we have done. So if I try to move my finger above it, see, I'm moving it fast. If I move it slower, it's really long. So move it faster, slower. Then if I move it much slower, how many LEDs are being counted on. So we move it fast, there's a single LED jumps. If I move it slower, then a lot of LEDs jump. So that's basically how we are going to do, or how we are going to build our circuit to work with you. So welcome very much, please enjoy. Hello guys, welcome to Tronics Energy. As we had done last time, or as we had said last time, that we are going to start off with doing some small complex circuits. So today I've done some circuit which I've called an infrared speedometer, and it's a pretty simple circuit. If you just look at it, it's just the same components that I've been working on some other projects. So supply voltage right here, I'm using the same as usual. I'm using a 5-volt power supply. It's a 5-volt power supply. This is an NE555. I know you might have seen me using it a lot of times. NE555. This is CD4017. I had used it back before making some really cool running LEDs on some really cool projects. And this is also an integrated circuit. This LM358, which is a dual comparator integrated circuit. So I'm going to use only one comparator on it. And these are our sensors. They are not really new. I've used them before. So this set right here performs as an infrared sensor. So right on this end, diode 1, this is the infrared emitter, or the infrared emitter that emits the infrared radiations, and this is the one that captures them and senses them back to the diode. So these two really complement each other, meaning that if something was to pass across it, then this will be showing you how much current is passing through, how much voltage is passing through it, compared to how close the object is on top of the sensors. So you pretty much want to use them close together to get the signal well. So once you are done with that, then we capture that into this comparator, in this non-inverting input. Then the inverting input comes from a V reference, which is a potentiometer set to a set value that will be used. If you want it more sensitive, or if you want it less sensitive, you need to vary this potentiometer. Then the output comes here, allows the NE555 to be on its oscillator mode. If you check this configuration, this is just an NE555 in oscillator mode. So this is to allow the ground pin to go to ground by passing through a current at the base, for you to provide that energy to run those electrons down there. So yeah, so this is simply the configuration. This is the capacitor, an electrolytic capacitor that I've chosen. It's a bit small. This is a 5.6 microfarad, capacitor, which is small because of the running LEDs. I need them to be fast because it's an infrared speedometer. This is just a replica, just something for fun. It's not a real deal out there. Maybe for those real speedometers, they use pretty complex circuitry more than this. So this is just something fun for you to do at home and try to replicate how speedometers work. So once you're done even with the NE555, then the output of the NE555 comes and controls this CD4017 at pin number 14, which is the clock input of our CD4017. If you check the data sheet of the IC, pin number 14 is the clock. So the clock, you feed it at the NE, you feed it with the NE55 or your pulse generator. Then clock inhibit, you need to ground it. Clock inhibit, you ground it. Carry out, you just leave it alone, we're not going to use it. Then the reset, I've used it, so I'll show you how I've used it. Then we have VDD, which is a supply voltage, VSS, which is the negative ground, and these other pins are the outputs to the LED. So these are the outputs to the LED. So as I said, pin number 14, you connect it to the NE555. Then reset pin, you need to use it. If you're not going to use the reset, you can just connect it to ground. But if you're using it, then you need to connect it in order to control how you want, or how you want your where you want your LEDs to start. So in my project, I've used it, and I'll show you how I've connected it. Then the others are the outputs, so you need to really know. So the first LED is pin number 3, second LED pin number 2, third LED pin number 4, fourth LED pin number 7, fifth pin number 10, sixth pin number 1, seventh LED I think is pin number 5, eighth LED pin number 6, ninth LED pin number 9, and 10th LED pin number 11 of the IC. So then you need to protect your LEDs using a favorable resistors compared to your VCC. So for me, if I'm using a 5 volt, I just need a 1K microfarad to protect my LEDs. So yeah, so that's basically how our circuit will be looking like. And yeah, so this is my circuit right here. It's not so complex, just exactly what the schematic looks like, only that the reset, I've not connected it to ground. If you check the reset, which is pin number 15, it's right here in this yellow jumper here. So I've connected it to a transistor at the base. I need to control the reset, or how I want my LEDs to run. So that's why I've connected it. So I've connected it to this transistor that I'll be controlling using this push button. So once they have run and my signal has reached somewhere here on maybe a yellow LED or a green LED, then I need to press my reset in order to get to start where I want. So if I want it to start at this middle part, or if I want it to start at this white LED, so I press this push button to get there. So that's pretty much exactly. So this I've said I've used 5.6 microfarad, and these are my sensors right here. They have favorable resistors. So for my transmitter, infrared transmitter, you have 330 ohm, and for my receiver I have like 10k microfarad, 10k kilo ohm resistor right there. And to connect them, they have different forms of. So for my transmitter, you need just to connect it directly, how you connect a diode for positive to positive, negative to negative. But for this receiver, you connect it like batteries, how you connect batteries in series. You connect it so for negative, connect it to positive, and positive, connect it to negative. Yes. And then you take your input right here to your LM358 for that variation. So this is the V reference that I was talking about, this one right here. R3. This is the reference. I can tune it to range how my or how I want my circuit to be sensitive. So if I want if my hand to be very up or my object to be very close, so I vary this resistance right there. So that's pretty much the circuit, and yeah. Okay, now let me power it. That's 5-volt power supply. Yes, 5-volt power supply, and I think we can start with our circuit. So now it's at a green LED, and we need to pass something on top of it to see how it functions. So let me sorry for that. So let me move my hand and check. So my finger is moving a bit fast. So if I move fast, just jumping to one LED, one LED. But if I move slower, then it jumps to a lot of LEDs. So you can take those many LEDs and put them into a calculation. Maybe that's a very low speed, but if I'm moving very fast, then it should not jump very much. So move slower. It has jumped to a lot of LEDs. So if I move fast, just one LED. Medium, just simple. It has jumped to LEDs. Just one LED. It has jumped to a lot of LEDs. A lot of LEDs. A lot of LEDs. So if it's there, if you want it to start maybe green or red, I can push this button to try and get where I want. So green, it's back to yellow, green there. Now it's red. Now I can start it there. So it's at the yellow. So I can push it again to get to start where I want. So if I want it to start at green, it's back at red. So I can, maybe I want it at white. Yes, it's at white. Then I can, yeah, you see. So you can count, you can say like 2 LEDs. If you jump 2 LEDs, then your speed is like this. If you jump 3 LEDs, then your speed is slower. Then if you jump like 5 to around 6 LEDs, then your speed is very low. But if you jump 1 LED, that means that your speed was very fast. So that's how you can use it as a speedometer to measure speed of objects moving in front of the sensor. So that's basically how the circuit works. Pretty simple circuit. You can rewind the video if you've not understood. If you have questions about this project, please comment. Ask me how I can guide you on how to really know how to make the circuit. The circuit, if you're having challenges and on building circuits using a schematic, I can show you how you can do it. So that's basically how the circuit is, and thank you very much guys for watching. Please subscribe to my channel, and really hope that we'll see each other next time, where we'll be doing even more complex circuits, more than this. I might even sometime buy another get another breadboard, make sure that I do even bigger complex, like components are here, then output is here. So big circuits like that, meaning that we are growing with time. So thank you very much guys for watching. Please subscribe to my channel, and we'll see you